Welcome back to GATE XAIML. So today we'll start with a new chapter called as random variables. From here we'll start building our probability distribution concepts. So let us try to understand in depth what is this random variables mean. Okay, once you understand this chapter in depth, so next chapters will be easy because this is the basic for probability distribution analysis. So let's start with what is random experiment. Already you have seen what you mean by random experiment. It is an experiment or a process that leads to one of several possible outcomes, where outcome cannot be predicted with certainty in advance. For example, tossing a coin. So there are two outcomes there, head or tail. So before we get the result, we don't know what is the outcome, but we know all possible outcomes. Why it is called random experiment? Because next we'll be studying about random variables. So let us understand this term random. Why it is called random experiment, just not experiment. See, why it is called so? Because its outcome is uncertain and unpredictable before it is performed. Even I know the outcomes. For example, say that tossing a coin, I know there are two possible outcomes, heads or tails. But till I perform that experiment and get the result, I am not sure like whether it will be a head or a tail. I know there are two possible outcomes. That is a reason. That is the random aspect here. What is the random aspect here? I don't know whether I will get a head or a tail. That is a random aspect. So randomly I can get a head or a tail. So that is why we would call it as a random experiment. Now we will try to understand, and these values may change for every time you perform that experiment, right? So that is why it is called as a random experiment. So what it means, if I toss now a coin, I may get a head. If I toss the same coin again, I may get a tail. So that is why it is called as a random experiment. Next, we'll come to the concept of a random variable. See, every time when I perform a random experiment, I will have certain outcomes. Now, what I say in generally, for example, say that outcome of a coin flip, you will have say head or tails. So you will say it in what? The words, right? You are saying it in words. Now, for mathematical analysis, if I say in words, getting two heads, getting three heads, getting five tails in a coin toss experiment. So it doesn't make that much easy to analyze it. Okay. If instead of that, if I give a number, they say that head means 1, tail means 0. So it becomes easy to do mathematical analysis. For example, it is giving roll numbers to you. So there are 50 students in a class. Okay, each has their name and details. So instead of that, I'll give say roll number 1 Abhishek, roll number 2 Akshata, roll number 3 Anil, like that. If I give, so I'm attaching a number to your name. So when I do some calculations or when I do display or marks or whatever it may be about your performance, then based on your roll number, it will be easy for me to analyze it instead of saying the names. The same thing applies here. In the real world, we conduct many experiments, we do many analysis. But if I give you statements, it's difficult to do mathematical analysis without the numbers. And also, one more thing is, see, everything, whatever you do, mathematical model has to be executed in a computer because you want to check your results in a computer. The computer doesn't understand heads, tails. If you say that 1 means head, okay, 1, what is how many times 1 is occurring, how many times 0 is occurring. So it becomes easy for the computer and for the developer also to implement that model. That is why you use the concept of random variables. The random variable is simple. You attach to a name, you attach some numbers, some numeric values, some real numbers. That is called as a random variable. For example, say that in this I may get head or a tail in the outcome of a coin flip. So I will assign head equal to 1, tail equal to 0. Now it becomes easy for me to understand, or for my computer or in my mathematical analysis to understand 1 means head, 0 means tail. Okay. A random variable is not the actual randomness itself. It is a numeric label we assign to the outcome of the randomness. The random variable is not itself the randomness. Randomness means you are just giving a random value. It's just a variable. Okay. Why do we need random variables? The real life experiment produce outcomes that may be words, events, or measurements. Numbers are easy to compare, record, and analyze. That is what I explained previously. Random variables acts as a bridge between real world randomness and mathematical reasoning. So a real world experiment can be used for mathematical reasoning and to build the mathematical models. Let us say, for example, why it is, if you see this example, you can appreciate like how good it is, why we need a random variable. Let us say I am predicting the outcome of a rainfall. Okay, so tomorrow it's going to rain. I am predicting. I have to predict whether it's a light rain, moderate rain, heavy rain. Now, if I say like this, what is that you will understand? How will you quantify this? How will you quantify this? Quantify means how will you, when I say something in words, how will you imagine it? Like quantification means how will you assign a number to it? Okay, if I say I have more money, if I say I have less money, what exactly it means? If I say I have 10,000, okay, that number, then you can analyze something, right? So similarly here in this example, light rain means, let us say in millimeters, 2 millimeter I assign for light rain. So in 4 millimeter for moderate rain, 8 millimeter or above I am say heavy rain. So now you can imagine, right? So if it rains around 2 millimeter, then I can say the rain is predicted, the rain is going to be light. If it is around 4 millimeter, then I can say the rain is going to be moderate. If it is more than 8 millimeter, then I can say it is going to be heavy rain. So now you can understand, right? So if I give some values, then I can easily analyze mathematically what exactly is the outcome. Okay, so I hope you understood this. So your textbook definition, what they say, random variable is you are just assigning a real or a numerical values to the your variable. That is called as a random variable. For your outcomes, you are assigning some values like head equal to 1, tail equal to 0, like that. It can be anything. It can be any number, not only 0, 1, 2, it can be any number. Now, there are two types of random variables. So one is discrete and another is continuous. In the mathematical analysis, the data can be of two types, not only random variables. Random variables is based on the outcomes, that is data. So in the real world, you can classify the data into discrete or continuous. So it is better to understand, because whatever you're going to learn about probability distributions, it is all divided into discrete and continuous distributions. Now, what do you mean by discrete random variable or set of discrete data? So which takes countable values like 0, 1, 2 or a finite set. So if you are able to count it, discrete means you are able to count it. Usually about counting the things. Examples, number of heads in a 5-coin toss. So example 2, 3. I can easily count. I'm not saying here 2.5, 3.6, right? It's 2 or 3 or 4 or 5, whatever it may be. Number of students absent in a class. I will say 10 students absent. I will never say 10.5 students absent, right? So I am easily able to count it. Marks in a test out of 100. Okay. So if it is a whole numbers, that is what's happening. If it is an integer, so I can say 90 marks. What exactly, how to visualize this? How to visualize this? Let us say there is a straight line. Okay. Now I am taking this die example. Say this is, it can take the values 1, 2, 3, 4, 5, 6. They are countable. Countable means what? Let us start with, this is the set. This is a discrete value. 1 I can represent. 2 I can represent here. 3, 4, 5 and then 6. See, I'm very clear about this point, no? On a number line. This is 1, this is 2, this is 3, this is 4, 5 and 6. So if you imagine something like this which is countable or discrete, okay? Now So if a random variable takes such kind of numbers which are discrete or which are countable is called a discrete random variable. So what does countable mean? As I explained previously, values can be listed one by one, even if the list is infinite. See, I can go on counting, right? Specifically 0, 1, 2, 3. So examples, number of heads in a 3-coin toss. It can be 0, 1, 2 or 3. Rolling a die, I can get 1, 2, 3, 4, 5, 6. Number of student absent 0 to some n value. Even infinite cases are countable. Number of tosses until first head occurs. This is still countable, right? If you remember, you used some geometric progression in the previous this one and then found out what is the probability, right? Even the infinite cases, I don't know till infinity I may go, but still it is countable. So such cases where you can specifically count the numbers is called a discrete, okay, data or discrete value. Next is a continuous value. Takes value from an interval of real numbers. Now, for example, say that height of the student. It is usually about measuring the things, okay, not counting, measuring. You cannot count here. When I say height of a student is 165.2 centimeter or 170.8 centimeter. Time to run 100 meter is 10.51. See, if I take 165 centimeter and then 170 centimeter, okay, 165, say 166, let us make 1 centimeter. 1 centimeter difference. This 165 is a discrete, 166 if I give it is a discrete. But when I say 165.2, okay, 65.2 here, there are countably infinite numbers here, infinite numbers between even 1 centimeter, this point. See, 165.0 to 165.2. See, there are countably infinite numbers between this. That is 165.1111 infinity, right? I can't count it. So this is a measured thing. So I can measure it as 65.5, 65.2. So since there are countable infinite points in between the real numbers or the numbers, then such things are called as continuous. I cannot represent discretely like this 165 or 166 because I cannot count them. So how you usually represent? You usually cannot have the discrete case like what you have done like this points here, no? Because there are many points here in between. So for that usually use the curves. Okay. So then we'll take the 165. This is 166. So they are continuous. I cannot differentiate between. So when I say in discrete case, I can directly say 165 is here, 166 is here. Okay, but here I cannot say that. It's a continuous thing. So it's between this 166 and 165. It's a continuous. There are so many points. A line has an infinite points, right? Like that. So how will you identify what does measurable means? The values cannot be listed one by one because there are infinitely many values between any two numbers. Think of measuring with real numbers. For example, height of a person. See, between 165 and 166 centimeter, infinitely many values exist. Okay, similarly to finish a race, it can be 9.85 second, 9.851 second, 9.8511 goes on till infinity. Right? So that's why it's a continuous random variable. Temperature. Okay. So how countable is discrete, that is counting marbles in a jar, for example. Measurable, continuous, measuring water in a glass. If I have a glass of water, how can you measure it? I cannot say exactly the quantity in milliliters, right? I cannot say exact quantity. So let us take few examples. Discrete random variables. Coin toss. If x equal to 1 for head, x equal to 0 for tails, it's a discrete. I can directly assign the number. Rolling a die, can show x equal to 1, 2, 3, 4, 5 or 6. Tossing 3 coins, so number of heads. So it can be 0, 1, 2, 3. Drawing a card, x equal to 1 if red, 0 if black. Marks in an exam, discrete if whole numbers, okay. I can get a marks like 90.5. Usually if we assume it as a whole number, then it is a discrete case. Number of goals in a match, a football match. Maybe 0, 1, 2, anything. So it's a discrete case. So what is the idea behind this? Discrete, counting the outcomes. Values can be listed one by one, 1, 2, 3, 4, like that. Examples for continuous random variables. Height of a person. It's measured in height in centimeter, like 175.5 centimeter, like that. Waiting time for a bus, X minutes waited. Okay. Marks in an exam, if decimals allowed, like 90.5. Temperature tomorrow, measured in degrees Celsius, 25.8 degrees Celsius, something like this. Life of a bulb, time until it fuses. Okay. So it can come for, say, 1.5 years. So what is the idea behind this? Continuous means measuring the outcomes, not counting. Infinitely many possible values in a given interval. Then it will be a continuous. Now you understood the basic concept of the random variable and discrete and continuous random variables. Now you'll understand what is this probability distribution. Once we know the possible values of a random variable, let us say x equal to 2 heads. Okay, 2 heads. Write like this, then coin toss experiment, where 3 coins are tossed, getting x equal to 2, that is 2 heads. Now I got this. The next step is to describe how likely each value is. See, in this experiment, there is x equal to 0 possible, x equal to 1, x equal to 2 possible, x equal to 3 possible in a 3 coin toss experiment. Okay. So now each one is likely, right? X equal to 0 is a likely outcome, 1 is a likely outcome, 2 is a likely outcome, 3 is a likely outcome. Now, what is this distribution means what? What is the likelihood of getting this? What is the probability? Likelihood means what is the probability of getting this? What is the probability of getting this? Those problems you already solved, right? Similar thing. What is the probability of getting this? That means what? If you assume this example, let us say x, so 0 heads, 1 heads, 2 heads, and then 3 heads. Okay. So this is a discrete case. Now, I'll attach a probability for each outcome. This is the outcomes, right? The possible outcomes. I will attach probability, certain probability to each of these outcomes. That means what? I am seeing how this probability, the probability is total 1, how this 1 is distributed among all the outcomes. This is called as probability distribution. Very simple. Okay. Don't refer textbook. If you can understand, you can understand the textbook definition. See, basically the probability, sum of all the outcomes in the sample space, the probability is 1. Now each outcome is attached to a certain probability. That means what is the probability of getting that outcome? If you add all that, you will get 1. So now you are distributing the probability among the different outcomes. So that is called as probability distribution. So what is the likelihood of getting, what is the probability of getting 2 heads? What is the probability of getting 3 heads? So this is the entire outcome or sample space. We call it as a probability distribution. So each probability is between 0 and 1. Sum of all probabilities is 1. That is what I say. Okay, we'll see example, you'll understand. See, there are again two cases here, right? Discrete random variable and continuous random variable. Now discrete random variable, for example, die toss. So this is what is given. See, getting say x equal to 1. Getting x equal to 1. What is x represents here? X is getting a certain phase that is die with 1 phase, 2 phase, 3 phase, like that. So getting 1, x equal to 1, probability is 1 by 6, right? This is what they return. So everything is a uniform here. All are equally likely. 1 by 6, 1 by 6. This is the distribution. This is the distribution. So for discrete, we know each points here, right? So that's why I have a bar graphs or line graphs. So these are called bar or line. So I can easily represent because it's a discrete value. Now for example, same thing, height of a person. So it is in a class. So this is the height, x-axis, and the y-axis is the density or the density function. I'll explain in the continuous probability distribution. So the probability again of what is this height. See, at this point it is around say 150.5.5, something like that. Here it is say 150.4.5, something like that. What is the probability of getting that outcome? Here it is discrete, I can count here, right? Probability is attached to each of the outcome, but here it is a continuous case. There is outcome itself is continuous, so it's a curve. So that is the difference between, you will represent it by these curves. So here I'll give a hint now only. So whenever I do, I will use summation, sum, because I can add 1, 2, 3, 4. Here I cannot add, so I will go for integration. When it is continuous case, it is curves, and mathematical operation I perform is usually integration. Here it is, you can represent by bars and lines, and then the mathematical operation I usually perform using the summation, that is sum of all, like that. Next, let us take an example. The random variable x. See, one more thing. The random variables usually are represented by capital letters. Capital letters are represented by capital letters. So equal to x means x represents the small x represent values. This is how you write. For example, x equal to x means the random variable, it assumes a value x equal to 1, x equal to 2, like that. Okay. Usually a, capital A means a random variable, y equal to a random variable. Usually represent in uppercase. The values are represented in lowercase, like this. Okay. So tossing a coin, it's a discrete probability distribution. So random variable x can take two values, right? 0 or 1. So let us say 0 means tail, 1 means head. How will you write this as a probability distribution? The probability of capital P, okay? For distribution, you usually write capital P. Probability of x is equal to 1. What exactly it means? Probability of getting a head. If I say in words, probability of getting a head. So I represent it using a random variable is equal to 0.5. This is how you write in the probability distributions. Similarly, rolling a die, probability of x equal to 3 is equal to 1 by 6. So in a discrete case. Similarly, tossing 3 coins. So I will say probability of x means getting heads, 0, 1, 2, 3 or heads. If I say x equal to 3, what it means? Probability of getting 3 heads, okay, in the coin tossing experiment. So this will be equal to, how will I get this? X equal to 3 means it is 1 by 8. In a discrete case, what it means actually, if I take it as a random variable, 0, 1, 2, 3, okay, 3, only this much. Now, probability of getting x equal to 0. See, there are how many outcomes? This problem already was solved. The sample space contain H, 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 okay, H, H, T. So like this you have total T, 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 8 outcomes, right? So for 8 outcomes, in that how many heads are possible? That is what I am finding. So 0 heads is probability is 1 by 8. 1 head is 3 by 8. 2 head is 3 by 8. 3 head is 1 by 8. So what I am saying, this is, if I draw a bar graph, this is 1 by 8. Okay. Next 3 by 8. Next 3 by 8. Next 1 by 8. Okay. So this is the distribution, probability distribution for this example. Okay. How means each random variable, that value is assigned certain probability. The probability is distributed among all these. If I add this, what will I get? You check it. Okay. Now, examples of continuous probability distribution. See, you already know in continuous distribution, so you cannot have the discrete cases. The curve is continuous. So, usually we will be given a curve like this 3x square. So, 3x square curve, you can see it here. So, this is the curve for 3x square. Okay. The left side indicates f of x. The right side, the x-axis indicates the x values. So, they are saying probability for the interval. So, probability distribution, how will you find? I told you cannot find directly like discrete values. So, I can take it in a interval of x less than 1. So, here I usually integrate, find the area under the curve. That gives the probability distribution. So, once I explain the distribution, continuous distributions, I will explain in detail. Okay. So, this is 3x square. If I integrate and then solve it, I will get 1. So, that is the value of the probability. That's what it says. Similarly, x by 2. This is the line for x by 2. This is a continuous. Okay. There is no discrete points here. So, that's why you use integration. So, if we want to find the probability of 0 x less than 1, this is equal to between the interval 0 1. So, integrate between 0 1. The area under the curve will give you probability distribution. So, what is that I am finding? 0 to 1. This is the area I am trying to find. Okay. So, it will to integrate, we will get as 1 by 4. This is how we will solve the probability distribution for continuous case. Okay. So, these were the basics. Hope you understand it. If you are not understood, please go through it once again before we start the next concepts, that is discrete probability distribution overview and continuous probability distribution overview. Okay. Thank you for watching. Please like, subscribe and share with your friends. Okay.